Greetings and welcome back to another video lesson by Mr. Nagengast. We are working with section 5.4, the sum and difference formulas for our trigonometric functions here, 9 and 10. So you recall that we are, again, dealing with these formulas, the sum and difference. We have the sine and the cosines and the tangents. So you should have these, just a reminder that we're working with these formulas at this time. So looking at number 9, we see actually two pieces of a function that we can work our sums and differences on. Looking at the sine x plus pi over 4, we'll see a u and a v. So let's deal with this one first. So there's my sine u plus v. So what that gives me is a sine of x times a cosine of pi over 4 plus a cosine of x and a sine of pi over 4. Now, this is all an addition. So there's my plus, and I'm going to take the second function and expand it using the sum and difference formula. So this time I get a sine x cosine pi over 4, subtract, because notice we have a subtraction right here. So we're going to subtract a cosine x and a sine pi over 4. Now what's really nice about this one is we'll see some opportunity for cancellation. You'll see that the cosine x sine pi over 4 cancels with its opposite of cosine x sine pi over 4, leaving us with two terms that are not only like terms, they're identical. So I have a 2 sine x cosine pi over 4. Now that, recall, is set equal to -1. There's our -1. So we have a -1 value on the right side. I'm going to change this cosine pi over 4 to its true value, which is a radical 2 over 2. That's a 45 degree for a cosine. So what I have is 2 sine x times radical 2 over 2 equals -1. Now hopefully you'll agree with me that you'll see a 2 canceling with the denominator of 2. And now my new equation looks like the following. I have a sine x times a radical 2 equals -1. Dividing each side by radical 2 gives me a -1 radical 2, which by rationalization will give me negative radical 2 over 2. So this is the value I'm going to work with. So the inverse of sine, or the arcsine, of this -2 or negative radical 2 over 2 will occur in two places. The two places this will occur is at 5 pi over 4 and at 7 pi over 4. So this is what my x value equals, those two values. Now just a quick reminder, when we are looking at the values for negative square root 2 over 2, that will happen for sine in these two quadrants, quadrant 3 and quadrant 4, and they'll be actually 45 degree angles. So they'll occur here and here. So there's our answer for question 10, or 9. For question 10, again we have two functions, and we'll be considering x is u and pi over 2 is v for this first one. So we've worked with this formula now. Let's use it again. We will have sine x of cosine pi over 2 plus a cosine x sine pi over 2. And that gives me my first value. My next value, and just for ease of use here, I think we're going to see if we can't move this down a little bit. And let's go on to the second part of this equation, which again now is an addition this time. So I'm going to add to it. And this time I'll let my u be x and my v be 3 pi over 2. So I have a sine of x times a cosine of 3 pi over 2. Subtract this time, we're subtracting. So we'll have a sine x, this time we'll be subtracting our cosine x and our sine of 3 pi over 2. Now, in the previous example, some things canceled. We don't have that happening here. So we're going to substitute in for each of these values of sine and cosine, which we are able to. So I'm boxing those in. Those are the ones we'll be able to substitute through our trig chart or using our calculator and computing, or simply through, at this point, memorization, because we've used it quite often. So in this first part, we will have a sine x, and the cosine of pi over 2, you'll recollect, is 0. So 0 times sine x is going to be 0. Plus, we have a cosine of x, and sine pi over 2 will give us a value of 1. Adding to that, a sine of x times cosine 3 pi over 2 will give me a value of 0 again. So one more time, this will become a 0. And cosine x and sine 3 pi over 2 actually gives me a value of -1. So with the cancellations of the zeros, I now have a cosine x times 1, which is a cosine x. And I have a negative cosine x times -1, which will give me a positive cosine x. That results in two like terms. With the two like terms, whoa. Oh, no. There's only one thing I can say about that is fuckataz. I thought Tweety Bird. Yeah, that's really about it. Wait a minute. Again, I did see a Tweety Bird. I did. Well, so long, Tweety. It was nice of you to join us. Anyways, let's finish up this problem. If we look at the two cosines, add them together, we get 2 cosine x equals, and if we go to the beginning of this problem, up on top, we'll see I'm having a little trouble here. The original problem was set equal to 1. Let's just verify that. So this is our original problem for 10. It is set equal to 1. So I'll solve the remaining equation. Dividing each side by 2 leaves me with values of cosine x equals 1/2. Or where does the angle x equal 1/2? Again, we can think of our circle, and this should happen in quadrant 1 and quadrant 4. And the value of 1/2 will be a 60 degrees here and here, or in radians that would be pi over 6, and in radians for this one we would have pi or 5 pi over 6. So my two values, pi over 6 and 5 pi over 6 for x. I will make a second video with some homework problems worked out and explained. So thank you very much and have a good evening.